We've been working on some seriously cool gaming tech with Sony, and I couldn't think of a better person to walk us through it than my good friend, Mark Cerny. Mark, thank you so much for coming out to Austin.
My pleasure.
I've asked Mark to join me to pop open the box and give you a peek at some of the gaming breakthroughs we've been working on together behind the scenes.
Yes, we've been busy, that's for sure. So today it seemed like it might be fun to share a bit about the brand new technologies being developed, starting with our collaboration under Project Amethyst to create the machine learning technologies of the future.
As every gamer knows, it takes a complex set of system expertise to get your setup and games to deliver the highest possible experience. As we progress together, the future brings us to real-time physics, cinematic lighting, efficient asset streaming, and keeping everything in sync across a CPU and GPU with super low latency. Trying to brute force that with raw power alone just doesn't scale. That's why we're combining traditional rasterization with neural acceleration. And machine learning isn't just a neat trick anymore. It's become a real tool for developers. Smarter pipelines, cleaner visuals, smoother gameplay, and more headroom to create the worlds we want to all get lost in. And that's what FSR is all about. FSR and PSR actually come from deep co-engineering between Sony and AMD. Co-engineering the neural networks that power both technologies. And going forward, more and more what you see on screen, the detail, the fidelity, the atmosphere, it will be touched or enhanced by ML. And that means we're not just hitting new technical benchmarks, we're getting closer to the vision of the artists and creators behind the games.
And the challenge comes in how we implement these systems. The neural networks found in technologies like FSR and PSSR are incredibly demanding on the GPU. They're both computationally expensive and require speedy access to large amounts of memory. The nature of the GPU fights us here. It's made up of a large number of compute units, and problems are therefore typically broken up into bite-sized pieces to enable the individual compute units to tackle them. And there's a downside to that. Subdividing a problem can cause inefficiency, or even force us to give up and find a different approach.
Exactly. And that challenge got us thinking, and what came out of it is something we're calling Neuroarrays. Here's the idea. Instead of having a bunch of compute units all working on their own, we built a way for them to team up, to actually share data and process things together like a single focused AI engine. Now, we're not linking the entire GPU into one mega unit. That'll be a cable management nightmare. But we are connecting CUs with each shader engine in a smart, efficient way. And that changes the game for neural rendering. Bigger ML models, less overhead, more efficiency, and way more scalability as workloads grow.
Neural arrays will allow us to process a large chunk of the screen in one go, and the efficiencies that come from that are going to be a game changer as we begin to develop the next generation of upscaling and denoising technologies together.
With neural arrays, we're unlocking a whole new level of performance for ML, not just faster, but more capable. That means better FSR, better ray regeneration, and brand new ML power features we're just starting to imagine. All working in real time, right on the GPU. And we're just getting started. As we look ahead, you also see dedicated innovations that bring cinematic rendering to an entirely new level.
Another area we've been focusing on has been ray tracing. When I look at its broad usage on PlayStation 5 for reflections, shadows, and global illumination, it's difficult to believe that it's been just 5 years since ray tracing was introduced.
Definitely, Mark. And now with path tracing becoming more central to real-time graphics, the demands on GPU just continue to grow. That's why we've been pushing hard to go beyond the current approach to help developers bring even more realism and cinematic lighting into their games.
But the challenge is that the current approach has reached its limit. To perform ray tracing today, a shader program has to juggle two very different responsibilities. One is ray traversal, digging through complex data structures to locate where the millions of rays being cast hit the millions of triangles in the scene geometry. When there are intersections, that same shader program has to also be doing its usual work of shading the scene, using texture and lighting information and the like.
And we spent the past 2 years rethinking the entire path tracing pipeline from hardware to software. Earlier this year at Computex, we introduced Radiance caching, a key part of FSR Redstone. Now, we're building on that with Radiance cores, a new dedicated hardware block designed for unified light transport. It handles ray tracing and path tracing in real time, pushing line performance to the whole new level. Together, these form a brand new rendering approach for AMD. Radiance cores takes full control of ray transversal, one of the most compute-heavy parts of the process. And that frees up the CPU for geometry and simulation, and lets the GPU focus on what it does best, shading and lighting. The result? A cleaner, faster, and more efficient pipeline built for the next generation of ray trace games.
There's a significant speed boost that comes from putting the traversal logic in hardware, and a further boost that comes from having that hardware operate independently from the shader cores. On top of those performance increases, there's other features in the works too, such as flexible and efficient data structures for the geometry being ray traced. Overall, I'm really looking forward to the time when we can get Radiance cores into the hands of game creators.
And we're excited to see how developers push ray tracing and path tracing even further with these tools. And here's the thing, whether it's ML or ray tracing, they both hit the same bottleneck. Current GPU memory bandwidth limitations hinder the seamless adoption of next-gen rendering techniques, requiring significantly more bandwidth to handle 4K plus textures and ray tracing denoising masks for smooth asset streaming. And that's where a final piece of news comes in, and yeah, it's a big one.
With current GPUs, including the ones in PlayStation 5 and PlayStation 5 Pro, we have something called DCC, or Delta Color Compression. It's a strategy that reduces the memory bandwidth consumed when the GPU is reading or writing certain data, such as textures or render targets.
And what we've built for future GPUs and SoCs take the idea of data compression much further. We call it universal compression. It's a system that evaluates every piece of data headed to memory, not just textures, and compresses it whenever possible. Only the essential bytes are sent out, which dramatically reduces memory bandwidth usage. That means the GPU can deliver more detail, higher frame rates, and greater efficiency.
Here too, I'm really looking forward to what improvements universal compression will bring, and to what degree the effective bandwidth of the GPU will exceed its paper spec. There's a multitude of benefits from this, including lower power consumption, higher fidelity assets, and perhaps most importantly, the synergies that universal compression has with neural arrays and Radiance cores as we work to deliver the best possible experiences to gamers. Overall, it's of course still very early days for these technologies. They only exist in simulation right now, but the results are quite promising, and I'm really excited about bringing them to a future console in a few years' time.
We feel the same way, Mark, and we're so excited to bring these innovations to developers across every gaming platform. Because this isn't just about silicon, it's about empowering the creators and communities that make gaming what it is. And we're just getting started. As we continue building with close partners like Sony, everything we're doing is focused on one thing, pushing games forward for all of you. Gaming has always been at the heart of what we do, and it's never meant more than it does right now. We're here for the players, the creators, and the communities that make this industry matter. And everything we're building is for you. Thank you, Mark, so much for taking time to join me here today.
Thank you, Jack.